Illinois Department of Natural Resources presents Hey, IDNR! How do I...
The clinometer is an instrument used to measure angles. To use the clinometer, simply hold it up to your eye. You'll have a hairline cursor in there, which will help you with the accuracy of your measurement, and you will also be able to see the angle flying around on a wheel on the inside. This particular model also has a window on the side, so a friend or a lab partner can help make sure that you get the correct reading from what you're seeing on the inside. Holding the clinometer perfectly vertical or horizontal will give you a reading of 0 degrees. And if you hold it perfectly vertically, it will give you an angle reading of 90. 0 to 90 degrees. Because the clinometer measures angles, it can be used to determine the height of large objects. This tree that you see, we're going to find out just how tall this tree is using the clinometer. The three basic functions of math we are going to use will be trigonometry, algebra, and a little bit of geometry as well. I made all of these measurements using the clinometer, neglecting my height. My height is about 2 meters, and I did not add that into the equation just to make things a little bit simpler. When you do this, if you want to get a more accurate reading of exactly how high the tree or whatever object it is that you are looking at is, you have to add in your height as well. So before you get started, you might want to measure yourself. There are 3 ways that you can use the clinometer to determine the height of a large object at a distance. The first one we're going to try, you need 2 measurements. First, you need to know the distance from the base of the tree to a starting point where you're going to make your measurement. I've already measured that out, and to this spot it is 25 meters. Second, you take your clinometer and you find out the angle from here to the very top of that tree. And that works out to be 35 degrees. Using those 2 measurements, here's how you find out how tall the tree really is. Here's the triangle we are going to be working with. We know a couple of the different quantities in this triangle. Through trigonometry, we know that the tangent of the angle theta equals the opposite side over the adjacent side. Now, with the measurements that we took, we know 2 of these 3 quantities, and that will allow us to solve this algebraically. The tangent of the angle theta, well, that for us was 35 degrees. That's what we measured with the clinometer. And our adjacent side to the angle is our 25 meters that we measured from the base of the tree to where we were standing. So now what we're looking for is the opposite side, which will give us the height of our tree. So let's plug in the numbers that we know. Tangent of 35 degrees equals opposite over adjacent. Now I'm going to change this O for opposite to an X so we don't have any confusion with this being a 0. X over 25. Again, that's the 25 meters from the base of the tree to where we are standing that we know. To get the tangent of 35 degrees, a couple of different ways. They have trigonometric tables. You can find out what the tangent of 35 degrees is, or the easiest way, pop that into your scientific calculator, make sure that it is on the degree setting, hit 35, tangent, and it will give you the number. That number is 0.7002. So let's finish setting up our equation. That equals x over 25. Now all we have to do is a little bit of algebra, and we will get this figured out. We'll multiply both sides by 25. Those cancel. That's going to give us x equals 25 times 0.7002, which works out to x equals 17.505 meters. We'll get that down to 1 decimal place. X equals 17.5 meters. That 17.5 meters was the height of the tree that we measured with the clinometer. The second way is using those same two measurements that we just took and using a piece of paper with a process called like triangles. Remember, this angle was 35 degrees and that distance was 25 meters. Here's how you use those two measurements to determine the height of the tree. This one's a little simpler, and unfortunately, it's not quite as accurate because you're dealing with your own drawing errors. What you want to do, we know that the base of the tree was 25 units. We'll just call it units. It was indeed meters, but we'll just use units for the purposes of showing you how to do this. 25 units we were standing from the base of the tree. So you could draw a line that's 25 units long. And again, I'm just showing you how to do this with for demonstration purposes. So this isn't going to be by any means exact. Now what you want to do is measure from the base of where you are standing, basically, is an angle of 35 degrees. And you want to draw that angle of 35 degrees using a protractor all the way past where the end of your 25 meters was. Then take a line, straight edge, and run it straight up. Where those two intersect, this distance should be the distance of the height of the tree. If this is done correctly, this is 25 units. This was 35 degrees. This line is the hypotenuse, and this line, which is opposite to this angle, should be 17.5 units. The third way to use your clinometer to determine the height of your object, in our case a tree, is to take your clinometer and walk towards the tree until you get an angle of 45 degrees on your clinometer. Once you get the angle of 45 degrees to the top of your object, stop. Measure from the base to where you're standing, and that is the height of your object. Here's why. Triangles will have interior angles of 180 degrees. That's the right angle in the triangle, so we know that this is 90 degrees. If we have this angle being 45, we know that that angle up there has to be 45 also, because both of those angles have to equal 90 degrees. And if that is true, that means this distance is going to be the same as that distance. So if you know the distance of this side with 45 degrees, you will know this distance and the side with 45 degrees. This will be the height of your tree.